Welcome to Notes 1.5. Today we're going to be talking a whole lot about angles. And we're going to start once again with vocabulary. So we've got complementary angles, which I'm sure you already know are two angles whose sum is 90 degrees. And then we have supplementary angles, which are two angles whose sum is 180 degrees. Then we have adjacent angles, which are two angles that share a common vertex inside, but no common interior points, which means that they don't overlap at all. Two separate angles directly next to each other. And then we have a linear pair, which are two adjacent angles whose non-common sides are opposite rays. In other words, if I were to draw them to make you understand a little bit better, I've got a straight line, just pretend it's straight, we all know, and I've got two angles. These two angles right here would be a linear pair because here are their non-common sides and they are opposite rays. And then finally I have vertical angles, which are two angles whose sides form two pairs of opposite rays. So basically what I've got going on here is I've got intersecting lines. And so I have essentially two linear pairs happening. But these would be my vertical angles, the ones that are across from each other. So this one right here and this one right here, or these two would be vertical angles. Bonus points to anyone who can spot the misspelling on this page. All right, so given our figure here, we need to name a pair of complementary angles. So we need to find two angles who sum up to 90 degrees, and I'm pretty sure it's these two right here. 52 plus 38 is 90 degrees. So we are talking about angle ABD and angle BDC. All right, my supplementary angles add up to 180, so 52 plus 128 is 180. So we're again talking about angle ABD, but its supplement is angle BDE. And then adjacent angles share a common side, so both CDB and BDE share side BD. So we've got angle BDC and angle BDE, who are adjacent. All right, so now we need to talk about vertical angles and linear pairs. So vertical angles, remember, are angles that have two pair of opposite rays. So for example, angle 1 and angle 4, angle 2, and angle 5, and finally angle 3 and angle 6. Those are all vertical angles. Okay, let's talk linear pairs. So linear pairs, we've given you the definition that it's two angles whose non-common sides form opposite rays. Well, we don't have two angles in this case whose non-common sides form opposite rays. So we're going to need to talk about three angles. So if I add angle 1, 2, and 3 all together, then I get essentially a linear pair. I'm so not crazy about this picture for this definition, but let's just go with it for right now. So angle 1, angle 2, and angle 3 are just one example of a linear pair, but any set that forms a straight line, so 2, 3, 4, 3, 4, 5, 4, 5, 6, you get the picture. All right, so we've got angle measures of 3x plus 8 and 4x minus 3 shown here, and we need to find angle BCA and DCA, and we know that these guys are a linear pair, and if they are a linear pair, then they must equal 180 degrees. So I'm going to take 3x plus 8 and set it equal to 4x minus 3. No, I'm not. See, even teachers make mistakes. I am not going to do that because what I just said was they equal 180. So I'm going to take 3x plus 8 plus 4x minus 3 and set them equal to 180. So I get 7x plus 5 equals 180, 7x equals 175. So divide by 7, and I'm fairly certain that I get x equals 25. Not my final answer, though. I have to plug it back in So for this side, I'm going to get 3 times 25 plus 8. And for this side, I'm going to get 4 times 25 minus 3. So the measure of angle BCA equals, what, 75 plus 8, so we're talking 83 degrees. And therefore, the measure of angle DCA equals 100 minus 3, so 97. And that makes sense because we knew these two were going to be supplementary. All right, two angles form a linear pair. The measure of one angle is 3 times the measure of the other. So we don't know anything about the measure of the other. We're going to make that x, which means that that angle is going to be 3x, and we need to find the measure of each angle. So 3x plus x, if they're a linear pair, they equal 180 degrees. 4x equals 180, which means that x equals 45 degrees, and 3x equals 135 degrees. So here we have some figures, and we need to solve for x and y. So remember how I told you x and y are never the answer? Well, in this case, they are. All right, so we have to figure out what we have going on. We do have linear pairs, but my linear pairs have different variables. So if I add them together and set them equal to 180, I'm going to need to solve a system of equations. I'm going to need to have two equations in order to solve it. So an easier thing to do might be to consider my vertical angles. And the nice thing about vertical angles is that they are congruent. So vertical angles are congruent, which means that I can set their measures equal to each other. So I can set 3x plus 7 equal to 5x minus 35, and I can solve it. And I can set y plus 75 equal to 3y plus 5, and I can solve it. So you pause the video and you solve for x and y. So you should have gotten that x equals 21 and y equals 35. If you have any questions on that, be sure to ask in class tomorrow. Moving over to our next figure, we've got some vertical angles going on, but if I try to set 5x plus 75 equal to 3y, that's going to be a little painful. So I should probably consider my linear pair. And if I consider this linear pair right here, then we have a single variable, which means it'll be easier to solve. And remember, linear pairs equal 180. So I get 6x plus 15x plus 75 equals 180. Go ahead and pause the video and solve that. You should have gotten x equals 5. So now we can solve for y. Now that I know what x equals, I can plug it in over here, which means that I've got 30. So now I have this linear pair. So now I can say that 3y plus 30 equals 180. So please solve this for y, which means that y equals 50. All right, now we have word problems. Yay, word problems. So we basically just have to translate. That's the word I'm looking for. Translate English to math. So I've got the measure of one angle is 3 times the measure of its complement. Well, here's one angle. We don't know anything about it, so we're going to call it x. And then its complement is going to be 90 minus x, because complementary angles sum up to 90 degrees. And is always means equal, and 3 times means 3 times. So basically, I have x equals 3 times 90 minus x. And I need to go ahead and I need to solve this for x. So x equals 270 minus 3x. Once I distribute, add 3x to both sides, I get 4x equals 270, which means that x equals 22.5 degrees. Decimals are okay in this case. And if x equals 22.5, then 90 minus 22.5 equals 62.5 degrees. So that is the measure, man, can't get a decimal point here. That is the measure of the other angle. 22.5 degrees is one, and 62.5 degrees is the other. All right, you guys pause the video and you try to set up this next word problem. Okay, again, I have an angle and I have its supplement. So this time we're talking about 180 minus x. And it says the measure of one angle is 38 degrees less than. So this less than causes me to flip, right? So I take 180 minus x and I subtract 38 from it, which means that I wind up with x equals 71 degrees. So if one angle is 71 degrees, the other angle must be 109 degrees since they are supplementary. If you have questions, be sure to ask about them tomorrow. So we're going to spend a little time right now talking about interpreting a diagram. And it's pretty critical in math that you know what you're allowed to conclude from a diagram and what you cannot. And basically, if I ask you why you think something is true, why is that a 90-degree angle? Why are those perpendicular? Why are those congruent? And your answer is, well, because it looks like it, that's not enough. Okay, so here's what you're allowed to say. If I have this diagram over here on the right, then I'm allowed to say that all points shown are coplanar. Right? My diagram is, unless I'm shown otherwise, my diagram's in a single plane, so all of those points are coplanar. And then furthermore, I can say that A, B, and C, those are all collinear. Right? They all lie on the same line. And I know that B is between A and C, all perfectly allowable. And then I know that line AC, ray BD, and ray BE, they all intersect at point B. Furthermore, I can say that angle DBE and angle EBC are what kind of angles? Fill in that blank in your head right now. Did you say acute? Did you say congruent? Because both of those would be wrong. I don't know anything about the measures of those angles. All I know is that they are adjacent because they share a common ray. That's the extent of what I know about them. And furthermore, ABC, because it is a straight line, I know that it is a straight angle. So that one I am allowed to say. All right. And then finally, I know that point E lies on the interior of DBC. It is on the inside of that angle. All right. In this diagram, however, I can't say that AB is congruent to BC unless it's specifically labeled like it is now. So now I can say that. And no matter how much DBE and EBC look congruent, unless I see this little arc showing me congruency, I cannot say that. I also can't say that ABD is a right angle, no matter how much it looks like it, unless I have this handy-dandy little box showing me that it is in fact a right angle. So remember, if I ask you why, because I'm always going to ask you to prove stuff, if I ask you why, and the answer is, well, because it looks like it, I might have to mock you mercilessly. Just saying. All right, this concludes Notes 1.5. I will see you in class. Thanks.